Good day, everyone. Today, we will continue with our lessons with a new topic for Chapter 5, which is I/O streams as an introduction to objects and classes. So, for this chapter, we will be talking about the following: streams and basic file I/O, tools for stream I/O, character I/O, and inheritance. In the past lessons, we've been talking about input and output. So basically, we've been talking about standard I/O using our basic C in and C out. So the point is, we can actually provide input and output for our programs using other methods. From what we have known, we've been only using the keyboard for providing input to our programs. And of course, we also produce the output by displaying them into our monitor. But actually, we can also do it using files. So which means we don't have to input something from our keyboard. Instead, we will simply load a file and let our program read the contents of that file as an input. And in return, we can also use a file to write our output instead of displaying it on the screen, or we can do both at the same time. So to start with, let's first talk about streams and basic file I/O. So when we talk about I/O streams, I/O actually refers to program input and output, as we've already mentioned a while ago. On the other hand, input is delivered to your program via a stream object. And of course, input can be from the very first thing that we learned, input from the keyboard. And of course, it can also come from a file. Output, on the other hand, is delivered to the output device via a stream object. And of course, the most basic that we know is to send output to our screen. And of course, what we are going to learn today is how to send output to a file. We will also learn some introductory topics about objects. Of course, we've been talking about objects, and although we're not really going to dig deeper in this subject, but it also makes sense that we are at least aware what objects are, especially in the context of programming and later on object-oriented programming. In its most basic, objects are special variables that have their own special purpose functions. And that's what sets C++ apart from earlier programming language. Actually, before C++ was developed, we really don't have a real concept of a programming language that actually supports object-oriented programming. So that was the moment that C++ was introduced, and that's the start that the concept of object-oriented programming has been introduced. Although right after that, a real object-oriented programming language was introduced when Java was created. To continue, so let's talk about streams and basic file I/O. So basically, files for I/O are the same type of files used to store programs. So which means any file that can be read and written to by a program can be used as file I/O for a program. So which means we can simply use text file, uh, DAT files, and some other files which can be supported by an operating system. On the other hand, a stream is a flow of data. So for example, we have the input stream, which refers to a file in which the data would flow into. And on the other hand, we also have input stream flows from the keyboard and the program will accept data from the keyboard. And of course, if input stream flows from a file, the program will accept data from the file. So which means an input stream can refer to a file which will be used as input for our program. We also have the output stream. So in this case, the data flows out of the program, or it can also be displayed to the screen or to a file. If we will recall, we have the cin and cout streams. So they are also considered as stream objects. Okay? So of course, we've already learned that cin can be used as an input stream connected to the keyboard, which receives input that we type. On the other hand, we have cout, which is of course the output stream connected to the screen. Cin and cout are defined in the IOStream library. So if we will recall, that's why we always use the following include directive to tell our C++ compiler that we would like to use the IOStream library, and in return, that allows us to use the cin and cout streams. Of course, you can also declare your own streams to use with files, which is what we will do for today's lesson. But first, why do we use files? Is there any advantage to it? Of course, there is. If we will recall, we only provide input using our keyboard and of course display the output using our monitor. So talking about complex programs, what if we will have to provide quite a big number of data sets as input to our program? So obviously, that is quite tiresome to input a lot of values or data or information using our keyboard. And at the same time, we only output the result of our program through our screen. And of course, the moment that our program execution ends, there will be no way for us to preserve the output of our program. So that's why it's better to use files. First, files will allow us to store our data permanently. So actually, that's the concept of databases. Okay, with databases, we can get our input from a record, and at the same time, we can put back the result of our program through our databases. So we can simply retrieve and output data using databases. So that's exactly the concept of why we are using files for our I/O to store data permanently. Also, data output of a file lasts after the program ends, as opposed to simply displaying it on the screen. If we output our result to a file, of course, it can be stored permanently, and at the same time, we can reuse that data in the future. And also, an input file can be used over and over, so which means we don't have to retype our input through the keyboard. And we create a data file or read an output file at our convenience. So that is much better as compared to providing input to our program using keyboard or using our screen to display the result of our program. Of course, that will also allow us to deal with larger data sets. So as we mentioned a while ago, we can actually use a large volume of input data if we are going to use files as opposed with simply using the keyboard. So talking about file I/O, of course, it involves reading from a file in which we take a file as an input to our program. And how do our program read the file? So it is done from beginning to the end. For now, we will be dealing with this method. Although it is also possible to read a file from any location that we want, but for now, as an introduction to file I/O, we will simply do the reading of file from beginning to the end. Hence, there's no backing up to read something again for now. Okay, just like providing input from the keyboard, so we do it in a straightforward manner. Although later on we will explore some other ways to read a file from any location that we want. And how do we write to a file? Of course, we do it by sending output to our output file. And just like reading, for now, we do it from beginning to end. Okay, and for now, there's no backing up to write something again. So we're just getting started with how to read and write to a file as I/O to our program. Next, we also have what we call stream variables. Just like any other variables, a stream variable must be declared before it can be used. And of course, it must be initialized before it contains valid data. Just like any other variables, before we can use it, we must declare it. And of course, it's a very good practice that whenever we declare a variable, let's make it a habit that we initialize it first. Of course, initializing a stream means connecting it to a file. Since we are talking about file I/O, the moment that you declare a stream variable, since you have the intention of reading input from a file or writing output to a file, so it only makes sense that you connect your stream variable to a file. And of course, the value of the stream variable can be thought of as the file it is connected to. So later on, we will see how it's done with a couple of examples. And of course, since it is also considered a variable, it can have its value changed. Changing a stream value means disconnecting from one file and connecting to another. Now, how do we deal with streams and assign it with a file? A stream is a special kind of variable called an object. And objects can use special functions to complete tasks. Streams use special functions instead of the assignment operator to change values. So what are these special functions that streams have? We will see in a couple of examples. So talking about stream as a variable, of course it needs to be declared. But how do we declare an input stream file variable? We will find out. First, let's make it clear that input file streams are of type if stream. And the type if stream is defined in the fstream library. So which means in order for us to use this type if stream, we must first include the fstream library. And of course, to do that, to load a certain library into our program, we need to put that in our include directive. So we will see that later on in our examples. And just like this one, you must use the include and using directive. So in this case, we included the fstream library in order for us to use our fstream variables. And of course, for standard I/O, we also need to use the namespace std. So that's actually not new to us. We've been using this one, the namespace std, for quite some time. Next, of course, we declare an input file stream variable using the following syntax. So for example, we now declare a variable of type if stream, and of course, our actual variable name. So it's still the same rule that we follow when we name our variables. So we just have to recall how we name variables. Just make sure that our variable names are descriptive, and of course, it makes sense. Now, how do we declare an output file stream variable? Actually, the entire process is quite similar, only that this time we are declaring a stream variable which will be connected to a file which will contain the output of our program. Output file streams are of type of stream. So a while ago, if you will recall, for input file stream, it was if stream. So this time, for output file streams, we have the type of stream. Next, type of stream is defined in the fstream library. So just like if stream a while ago, of course, in order for us to use the offstream data type, we must first include the fstream library in our program. To do that, we also use the include directive, which includes fstream, and of course, we also need to use the namespace std. And we declare an input file stream variable using the following syntax. Offstream as the data type, followed by your variable name, which would describe the variable which will be used as output file for our program. And as we've mentioned a while ago, after you declare your fstream variable, whether it's ifstream or offstream, you need to connect them to a file. So once a stream variable is declared, we need to connect it to a file. So that would tell us our compiler which files to use for input and output. So connecting a stream to a file would result to opening the file. So which means once a file is opened, it is now available for reading as well as writing an output. So we use the open function of the stream object. So here's an example. This is the fstream variable that we declared. Then, to open the file that will be used for input, we will simply call its open function. So how do we call functions of an object? So in this case, inStream is actually an object which was originally declared as an ifstream variable. So to do that, we call a function by using period. Okay, so inStream dot open. So that will call the function open. And of course, if you will notice, the open function requires an argument. Okay, so since it is an fstream variable which will be used for opening a file, the argument that it requires is actually a file name. So this is the file name of the input file that we will use, and of course it is enclosed in double quotes. And of course, just like a regular C++ statement, it is terminated with a semicolon.